Okay, so so you can hear me, I hope.
Yes, sir, we can hear you.
Okay. Okay, so let's move to the next slide. Okay, so we started the history a bit. This is just some highlights, you can say. And so the most important thing actually in the history of laser, I mean, the ruby laser, which was invented by the Theodore Mayman. He was basically an engineer, and he was working in a huge research laboratories, and that first time he worked on it. So you can see this is the Mayman, and here you can see the first ruby laser actually. Here, this one is first one. The flash lamp here for a pumping. What is pumping? We will see later on. Okay, and inside of this flash lamp, there is a rod actually surrounded by this flash lamp. So here you can see this is the ruby rod, red one, and this one is surrounded by the flash lamp. So this is basically pumping and etc. That we study. I mean, what is this? So this animation is showing that how ruby laser works, and ruby laser was pulsed laser. Okay, and the pulses, the first time it was nanosecond probably, and the ruby wavelength is around 600 something. I don't know. I mean, I don't remember exactly. Okay, so the construction, I mean, this kind of thing is it's not here, but later I will see if I have enough time, because this is also category of pulse laser. Okay. So the next one actually is helium neon laser. Helium neon laser is one of the important laser, I mean, in the labs, undergrad labs and grad labs, even in high school. And this laser actually, it was invented by Ali Jawad, and it has a mixture of two inert gases, which are helium and neon. And you must have seen this kind of laser in the lab somewhere. Even the students from Pakistan, I think they must have seen this kind of thing. When it glows, it looks like this. Okay, it has a tube, and inside the tube, the mixture of helium and neon is filled with a certain percentage. Okay, so this was invented in 1961. And helium neon laser is not a pulse laser; it's CW, continuous. It generates the laser continuously. Okay. Here, if you go to the channel, my channel actually, this is the channel, virtual group channel. So this is, you can see this is here, the helium neon laser is glowing here. Okay, and you can hear me? You people can
Yes,
hear
sir,
me?
we can hear you.
Yes.
Yes.
Yes, sir, we
Okay,
can hear you.
yeah, sure. Okay, so this one here you can see, I mean, this is the real one. I took it when I was at lunch actually. I opened and removed this the light from the case. And how does it look like? Okay, glowing continuously, red, kind of 632, I think, something like that. And if you want to see, I mean, you can go to my channel and you can see, and here as well. Here I am explaining somehow the parts of the helium neon laser, what it has, the cavity mirrors, and etc. etc. Okay. So if you want to know, you can tune to this channel and you can see. Here I'm just giving you introduction. That is why I'm not telling you all these things. Okay. So after that, okay. So that was helium neon. And in around 1962, the semiconductor laser actually basically also CW laser. And it's invented by the Robert Holnick. And this is uh, basically a CW laser, but some of semiconductor are also existing which can emit pulses. Okay. So this is easily available in the market. You can see this is a small laser. Okay. Um, and the basic first time when it was invented, it was in IR region, the emission. IR region means the infrared region. Then laser, and then red color. This one is red color, very easily available. And it has same structure, same like when we study the PN junction. Okay. So the lasing is coming out from the junction where the P and N connected, and they have a junction. Okay. I'm not going in detail. Okay, what is P and what is N? I'm just telling you here. So when this laser, this one, when it glows, you can see here it looks like it's a CW here, and you can see the tiny kind of somehow like LED, but not LED. Okay, so so after that, N2 laser, nitrogen. And nitrogen laser, actually, it's first time uh, it was developed by Hurd, and this is 1963. I couldn't find the picture of this guy, uh, but this is the simplest laser actually. When you can use the air, even you can use the air to have this laser. Probably Salman, Nabil, and uh, who worked there with me during my stay at the ComSat. Probably they know.
Yes, sir.
Yeah. So there was a project, I mean, some of my students to build this one. And before that, also around 10, 12 years back, one of my students actually, first time he made this nitrogen laser at LUMS actually.
We use flyback transformer.
Yes, yes. Okay, so this is a nitrogen laser, two possibilities, whether to use a nitrogen in a closed cell or a certain percentage, some other gases also. Other possibility to, we have around 76% of nitrogen in the air. So that we can utilize to have a lasing in the air with a certain arrangement, high voltage discharge in the air. Okay. It's not so simple to have this lasing. And this nitrogen laser is a pulse laser. It cannot have a continuous emission. Okay, it's a pulse laser and nanosecond range. This video, I mean, you can also find on my channel. This is the first homemade nitrogen laser, and this was built by one of my students at LUMS actually. It's a long time back. And you can see here, these are the plates. It's kind of capacitor, okay? And there is a dielectric in between the plates. And we have a cavity here, kind of. And the high voltage actually is produced. We need to have high voltage and discharge in open air. And then you can see here this UV region, okay? This UV region. You can have this emission. I cannot tell you in detail this kind of thing because this is just introduction. I'm just showing you. So you may have some kind of interest. And here, these are the steps. If you are interested, you can go to my channel, and this is a group channel, and you can see the step here, how it is built. I mean, with the power supply and some aluminum sheets, and then you have a dielectric, and then it's a big size capacitor. Okay, so discharge in a year. And so after that, okay, the fiber laser. The fiber laser actually, it was not so popular in the beginning, and it was invented by Elias Snitzer, and it's 1964. Popularity of the fiber laser actually entered around for last 10-20 years. And fiber laser is a category of solid state laser. Okay. So certain kind of fiber is made with some impurities, and so it has a lasing action. Detail is not a simple story. Just I'm showing you diagram here, that these are the basic components in all kind of laser. You need optical mirrors, cavity mirrors, and gain medium, and something like this. And here, when the fiber laser is working, you can see like this. And fiber laser is pretty useful in these days, even for high power stuff. And after that, a very important laser that we call anti-Yag laser. So anti-Yag laser basically, it is the emission wavelength of actual anti-Yag laser is 1064 or 53, I think. It was invented by the Joseph in 1964. It was in the Bell Labs, America. And but we use mostly Yag laser as a pump source to have a lasing from the other lasers, like titanium sapphire or something like this. So anti-Yag laser, we use the doubled, I mean, second harmonic of anti-Yag laser, which is green color. Half of 1053 is 532. So mostly we use Yag laser in the form of a green laser, okay, using the second harmonic generation crystal. That is a complex story, but anyway, so anti-Yag laser is very important. You can see here, this is the rod, anti-Yag laser rod. It's not used in the form of a crystal, it's used in the form of a rod, okay. And here, if in this animation, you can see that this is your anti-Yag rod, and these are the flash lamps around it, okay. So these flash lamps are used as a pump source to have a stimulated emission, okay, stimulate, and then lasing to happen and come out from one side of the this Yag rod, okay. One of the side of the rod is fully polished, other one is partially polished, and what this fully polished and partially polished, it will come later. So if you want to see the green color Yag laser here, you can see here, and this green color, all this green color is because of the Yag, but it is frequency doubled, okay, half of the actual wavelength. And this one is here used for pumping the TISAF laser or whatever. And Yag laser is CW laser, and it's possible to have a pulse Yag laser as well, okay. It depends on the pumping, okay. So if you pump continuously or if you pump in the form of pulses, okay. So after that, that's very important laser in the history of lasers. That is carbon dioxide laser. And carbon dioxide laser, first time actually it was invented by the Kumar and Patel, and it was 1964. So after the invention of the ruby laser, it was the progress was pretty rapid. Okay, so in the development of the lasers, and so 1964, the first time he actually demonstrated this carbon dioxide laser. Carbon dioxide laser basically, as you know, it has a carbon dioxide laser inside the cell tube with a mixture of some other gases also. And there are two kind of carbon dioxide laser. Usually carbon dioxide laser is CW laser, okay, continuous. In some cases it's possible to have pulses, but not always. Some of the carbon dioxide laser exist in the form of seal tube, like it's coming from the factory. They seal the carbon dioxide, some other percentage of gases, and you need to have like other things, cooling system and some power supply sources and etc. Other thing is that to make a you fill up the carbon dioxide gas. You cannot fill up. You have to supply continuously carbon dioxide laser with a and vacuum pump and cylinder to use it, and to inject this carbon dioxide laser here continuously, and you have a discharge with a high voltage discharge inside the tube, so stimulate, and then you have a stimulated emission. And this is, if you see here, this one we tested in the lab at ComSat, this homemade. We use the seal tube type, but the rest of the thing actually we made there. One of my student, probably Salman and Nabil, they must have seen this setup there. And here, if I click here, you can see here, you will see the
Yes, sir.
the glowing of this is a carbon dioxide. Okay, like this, and it was around 40 watt or something like this. And here, if you see this one, this is all homemade except the seal tube carbon dioxide. There's a power supply source here, and this is a tube, and here the chilling system, because when it lasers, it heats up a lot. So when it heats up a lot, then definitely there is a problem. So we have to compensate. So we make some homemade kind of chilling system to heat up, to cool down the tube. And here, if you see, there are different kind of seal tube carbon dioxide lasers are existing. Okay, definitely it has different powers. Okay, so after that, this is argon ion laser. Argon actually is a gas, definitely inert gas, but this in this kind of laser, the argon is used in ionized form. Okay, it's a complex kind of the construction of argon ion laser. Here you can see, I'm not going to explain here because it's not it's not included in this course actually. But argon ion laser is CW laser, and CW laser means it's a continuous laser, and it's a tunable laser. Tunable means that we have a certain arrangement inside of this laser that we can have a different wavelength at the output. Okay, so probably we can use some grating inside, or we can use some prism set inside, and we can tune, and we can have some different wavelengths: red, green, blue, violet, something like IR maybe. It depends. So this one you can see, I mean, it's in the lab. It's a real argon-ion laser, which was in the lab at LAMS, actually, Pakistan. And it was operational. The argon-ion laser is very important in laser shows. Okay. It's not very high power, and for the cooling, we don't need water. With the fan, we can just cool down. Okay. So in the laser shows, now there are different kind of lasers, like they are using the semiconductor lasers and etc. But before, actually, still even argon-ion laser was very popular in the laser shows. Okay. And here, this video, it shows the operation of the argon-ion laser. You can see here, this color is tuning. Okay, it's a CW, it's a tuning, and you can see the different wavelength. Blue to violet, you may not distinguish much, and you may also see some green. Like here, you can see now the color is changing here, and here as well, red, and some of the colors are very intense, some of the wavelengths are not very intense. Okay, but this is a green you can see now, and this is a one laser, and we're tuning it. Okay, and it's very colorful and fascinating kind of thing. I mean, if you see real in the lab, pretty unfortunate in Pakistan, actually. The students cannot. So anyway, you can see now blue and different colors here, and this is, so it's argon-ion laser. Argon is used in the form of ion. Okay. So next we move to the next, I think it's the last slide. And this one is one of the powerful lasers in the world. It's chemical laser. And the chemical laser, basically, it was invented by the George Emmental, and it's 1965. So it was at the University of California, Berkeley, and the chemical laser, at its name shows, the chemical actually used, and it's a pumping is not like other lasers. I mean, the pumping is like a chemical reaction. So high power lasers, laser weapons, are in the category of chemical lasers before. Now we have other technologies, diode laser, solid state we can use as well. But before, I mean, the chemical laser. So chemical laser is a huge laser. Usually it's the size of, I mean, it can be on the optical table, very low power, but usually it's the size of room for high power to use as a weapon or in the industry. So what exactly happened? They used two kind of chemicals, and they separated two chemicals, and when they want to react and to generate the laser action to happen, they remove the partition, and the two chemicals, they react with each other, and the pumping is started, and the laser happen. So there are very few labs in the world now that are working on it. Chemical laser is also dangerous. I mean, if you need to handle it very carefully, it can damage your body definitely severely. And there are certain precautions in the chemical lasers. So another laser, but I don't think it's there. Yeah, it's finished. That is called dye laser. I didn't mention here. The dye laser, basically the dye, you know, the dye which is used to color the hairs and the colors different clothes. So this kind of dye is used to generate the laser. Okay, and this dye lasers, I mean, it was very important. I mean, it's like 1990s to have a femtosecond laser. Before the discovery of TISAF, that TISAF can be used as a femtosecond laser. So you can say ultrafast laser. So the dye laser were used to be. So this was the first this lecture. And
Excuse me, sir.
so now if you have any question, you can ask. Yeah.
Sir, is the lecture end?
Yes. Yeah.
I have a duty to move for.
Sorry.
I have to duty.
Okay. Sure.
have a
Sure.
duty to move for.
Sure.
Mail.
Yeah.
Okay.
Sure.
Okay,
Sure.
sir.
Thank you very much.
Thank you, sir.
Thank you.
Love this.
Okay, so all of you, I mean, if you people are having any question, what was in this lecture, so probably you can ask. I mean, I can have 5 minutes or so. So probably, if you want me to share again, I can share it. But if you don't have, then we can meet in the next class.
Sir, I have a question.
Who are you?
It's Ali
Ali.
Hassan.
Yes.
Sir, when we were seeing argon laser, there were different colors and the light was spreading.
Mhm.
I mean, it was fully spreading on the screen, but
Yes.
usually laser do not spread.
Yes.
It's monochromatic. Why
Yes,
it was spreading?
but there was always some the particle in the air or on the paper or something like this, where the scintillation can happen, scattering can happen. Okay, so this was the scattering that was scattering
That
you would have
happens.
seen.
I think
Now, if the
it
laser
looks
is
like
very high power, listen, if the laser is very high power or even medium power in the normal lab where there is no like not a concept of clean lab, there are so many dust particles. You can see these kind of things always in the lab. But actually laser, and also this laser, because it's needed some tuning as well. It was very old, so it also needed some tuning.
okay.
Okay. So I mean, the new guys like Arusa, I mean, did you understand the things today? Arusa Hadi.
Yes, sir. Yes, sir. You explained very well. Thank you so much. I enjoyed the whole.
Okay. And Tahura, I think it's first time for you, Tahura.
Yes, sir. The session was amazing. I got some amazing points from this lecture.
Mm-hmm. Okay, good. And who is this? Shoaib Mustafa?
Shoaib, sir.
Yeah.
Yes. So you mentioned that there are very powerful lasers from 10 or 20 watts even, and even petawatt lasers. I have read about the lasers that usually they are very inefficient, and especially when we talk about the visual lasers, the visible lasers, they are more than 50%. That's what I read. I hope I'm not wrong in that. If that is the case, how do they justify that much loss in such a
Yeah, I mean,
high-powered system?
efficiency. It's not easy to generate petawatt. Okay, I think you need to wait a bit to go further. Probably you will get your
Okay, sir.
answer.
Okay.
And also, I mean, if you go to that, as I told you, that in UAE, that directed energy kind of thing, they are also working on the petawatt lasers. So it's not simple to generate petawatt, okay, but still achievable. But there are many things. Later on, you will see how it is. Okay. Okay. So my students from David, do you have any question?
No, it's okay. Thank you very much.
And Diago?
Everything okay?
Okay, that's good.
Sir?
So, yeah. Yes, Zanfar.
Sir, can you hear me?
Yes, I can hear you.
Sir, I have one question. In your slides, you are showing the organ laser which changing its light color,
Yes.
its wavelength.
Yes.
How is possible from one laser we can? I think there are different energy levels, and this
Yeah.
The main
Yes.
the question
Yes.
the question which I want to ask. Yes, this is due to the we are changing the power, pumping power.
No. This is no. This is not at all related to. This is related to the gain medium from where the laser is generated. So not all the medium can have this thing. This is the specialty of argon-ion laser. When you study its structure, the energy levels of argon-ion laser, you can easily understand this one. Okay, not all the laser. It's not that
so
all.
We can control
Yeah. Sorry.
We cannot control this thing, or this is the random.
No, this we can control. This all the wavelengths are coming out at the same time. We just use the prism or grating to tune.
Yes.
Okay, so but it's not very high power. It's a low power kind of thing. But argon ion, this has. I mean, this is specialty of the argon ion. Okay, so yeah. So Amna Saeed, I think it's new for you as well. This laser. How do you feel about it? Amna Said. Can you hear me, Amna Said? Mauricio, I mean, do you have any question? Did you understand?
Yes, I could understand.
Okay.
It was a good introduction.
Okay.
Lasers.
Okay.
Well, I have a pre-knowledge about
Yeah.
that because I worked in a little project with a pulsed infrared laser.
Okay.
To
Yeah.
make to excite some rare earth ions and trivalent ions.
Okay. Okay, I mean, definitely you have advanced knowledge. Some of the people are having advanced knowledge, but some of the people are very basic. So that is why I started from the basic. So Amna Said, do you have any question? I'm asking especially the people who are like new in this kind of field. Amna Said, can you hear me? Ihtisham is okay?
Yes, sir, I have understood it.
Okay.
The whole lecture.
Okay, so it's okay. Thank you very much for your
Sir,
time.
I have a question, please. Sir, you know, there are a lot of concepts involved in like learning such stuff. What kind of text do you recommend that we could
You can
follow along with this?
Yeah, I mentioned the text actually. If you go to the website, the virtual laser group, there are you can go to the courses and etc., the training and courses, and you can see the outline I uploaded there. So in the outline I mentioned the books, and you can buy my books as well actually. They have the basic introduction as well, 2 books, which are carbon dioxide and the nitrogen laser. Okay, and it's very cheap actually. So Amna says, do you have any question? I don't think she has any question. Okay, so thank you very much, all of you, and I hope to see you in the next class. Thank you very much for your time and attending this class. Okay, bye.
Bye.
Thank you, sir.
Thank you.